In Python, type conversion, also known as typecasting, is the process of changing a value's data type from one type to another. This concept is essential when working with mixed data types or ensuring compatibility between different values. For example, we might want to combine an integer with a string or perform calculations between floats and integers. Type conversion enables this by changing the data type to one that matches the context. This is an essential programming concept as it allows us to work with different data types and perform various operations. Type conversion is a fundamental concept in Python and plays a crucial role in various aspects of programming. Here are some key reasons why type conversion is important. Data compatibility. Type conversion ensures that different data types can work together seamlessly. For instance, when performing arithmetic operations involving integers and floats, Python automatically converts the integer to a float to avoid data loss. This compatibility allows for smooth execution of operations without runtime errors. Prevents runtime errors. Type mismatches often lead to runtime errors, especially when combining or comparing incompatible types. For instance, trying to add a string and a number without conversion would throw an error. Type conversion avoids these issues by converting data types in advance to ensure the operation succeeds. Data handling flexibility. Type conversion allows us to handle data more flexibly. For example, converting user input strings to integers or floats allows us to perform mathematical operations on them. Optimize performance. In some cases, type conversions can lead to performance improvements by allowing data to be processed in a more efficient format. For example, converting large integers to smaller types when they are known to fit within a certain range can optimize memory usage and processing speed. Enhances code readability. Explicit type conversion can make our code more readable and maintainable. It clarifies our intent, making it easier for others or ourselves in the future to understand the code. Before diving into the discussion on type conversion, let's first talk about the type function in Python. The type function is a built-in Python function that helps us identify what type of data we're working with. It's like asking Python, what kind of data is this? The syntax for using the type function is type of object. Object is the variable or value whose type we want to determine. The function returns a type object that represents the data type of the specified object. Consider these examples. Here, we've defined variables of various data types. We used the type function to determine the data type of each variable and printed the results. For instance, the integer variable, holding the value 10, is of type integer. When we pass it to the type function, it returns class int. Similarly, the data types of other variables, float, Boolean, string, and none type, are accurately identified and displayed. Remember, type function doesn't change the data type. It just tells us what type the data is. If we need to change the type, we'll need to use type conversion functions, which we'll cover next. There are two main types of type conversion in Python: implicit type conversion and explicit type conversion. Implicit type conversion, also known as automatic type conversion, happens automatically when Python converts one data type to another without explicit instructions from the programmer. This type of conversion occurs when Python determines that it's safe and logical to perform the conversion, such as when mixing different types in an operation. Let's look at an example to make this clearer. Nomint equals 5. Nomfloat equals 4.0. Result equals nomint plus nomfloat. Print result. We execute the script to see the results. In this example, Python changes the integer nomint, which is 5, into a float before adding it to another float. This gives a result of 9.0, which is a float. Python does this automatically because adding an integer to a float means the integer needs to be converted to a float to keep the result accurate. This kind of conversion happens silently, without any intervention from the programmer. Python does the conversion behind the scenes to ensure that operations between different types proceed smoothly. Implicit type conversion is possible only when there is no loss of information or precision, and the conversion is safe. Explicit type conversion, or typecasting, is when the programmer manually converts one data type to another. This is done using specific Python functions, such as int, float, str, and others, to force the conversion. Explicit type conversion is done using special functions called common type conversion functions. These functions allow us to convert a value from one data type to another. Here are some common type conversion functions. X is set to 10 as a string. Y equals 5. X equals int of X. Result equals X plus Y. Print result. We press the Run button to start the code. Here, X is a string and Y is an integer. To add them together, we use int of X to convert the string to an integer, and then we add it to Y, giving the result 15. Let's see what happens if we don't convert the type. First, we comment out the conversion line and run the program again. As you can see, the execution failed and type error appeared in the output. This error tells us that string and integer cannot be concatenated together. Since it doesn't know how to automatically convert them, it can't perform the operation. We uncomment the type conversion line and run the program again. This time, explicit type conversion is performed, and the sum of 10 and 5 is displayed in the console as 15. The float function is used to convert a number or a string that represents a number into a floating point number. Floating point numbers are numbers that have a decimal point. This function is useful when we need to perform arithmetic operations that require decimal precision. Let's take a look at this example. Nom_str is set to 3.14 as a string. Float value equals float of nom_str. Print float value. This line creates a variable named nom_str and assigns it the string value 3.14. Here, 3.14 is a string, not a number. This line converts the string 3.14 to a floating point number using Python's built-in float function. The resulting value is stored in the variable float value. This line prints the value of float value to the console. The output will be 3.14. By explicitly casting nom_str to a float, we enable numerical computations with its value. We can convert integers or floats to complex numbers using the complex function. A complex number has a real and an imaginary part. For example, nom equals 5. Result equals complex of nom. Print result. First, we create a variable named nom and assign it the integer value 5. Next, we convert the integer value of nom to a complex number using Python's built-in complex function. Since we only provided one argument, which is 5, Python sets the real part to 5 and the imaginary part to 0, resulting in the complex number 5 plus 0j. Converting to Boolean. The bool function is used to convert a value to a Boolean type, which can either be true or false. This conversion is based on the truthiness or falsiness of the value. Before diving into the bool function, it's important to understand the concepts of truthy and falsy values. In Python, every value can be evaluated as either true or false when converted to a Boolean. These are categorized into two groups. Truthy values. These are values that are considered true when evaluated in a Boolean context. Most non-zero numbers, non-empty strings, non-empty collections, and objects are considered truthy. Falsy values. These are values that are considered false when evaluated in a Boolean context. Common falsy values include none, false, 0 of any numeric type, empty sequences and collections, and custom objects that implement the dunderbool or dunderlen methods to return false or 0. Python considers certain values to be truthy, meaning they evaluate to true in a Boolean context, and others as falsy, meaning they evaluate to false. Knowing which values are truthy or falsy helps when working with conditions, logical statements, and conversions. Let's return to the IDE and demonstrate this concept with a real-world example. We've set the user input as an empty string and the default value as default. Result equals user input or default value. Print result. In this code, user input is an empty string, which is considered falsy in Python, while default value is default, a truthy value. Using the OR operator, Python assigns the first truthy value to result. So when user input is falsy, print result outputs default because user input was empty. This technique is useful for setting default values when a variable might be empty or undefined. Let's see how these values behave when converted using bool function. Here are some examples of how various values convert to booleans using bool function. The bool function is used to convert a value into its equivalent Boolean form, true or false. It follows Python's truthy and falsy rules when determining the Boolean outcome of a value. To see bool function in action, consider this example. Value equals something. If bool of value, print value is truthy, else print value is falsy. The code snippet checks if the value stored in the variable value is considered truthy or falsy in Python. The bool function converts the value to a Boolean. In this case, something is a non-empty string, which is considered truthy. Therefore, the if condition is met and the message value is truthy is printed to the console. Converting values to Booleans is helpful for checking if something is true or false. We often use this in if statements. What's interesting here is that the code works correctly even without using the bool function. If we remove bool function and use only the value variable, the output remains correct after execution. Since something is a non-empty string, it evaluates to true. So, why do we need bool function? The answer is one word: readability. Using bool function in Python enhances readability and clarity by making the intent of a truthiness check explicit. It ensures that the value being evaluated is of the Boolean type, which is crucial in certain contexts or when interacting with systems that require strict true or false values. Additionally, bool function helps avoid potential pitfalls in complex expressions, making the code more readable and understandable, especially for those unfamiliar with Python's implicit truthiness rules. The str function in Python is used to convert various data types into their string representation. This function is particularly useful when we need to concatenate numbers or other non-string types with strings, as Python does not allow direct concatenation of different data types. For instance, see how str is used here. To start, let's set num1 to 12 and num2 to 34. We want to concatenate these two variables to create the string 1234, so we join them together and store the result in the variable result. Then we print the result. Now let's run the program to see what happens. As you can see, instead of displaying 1234, the output shows the number 46. This happened because Python added the numbers 12 and 34 as integers, giving 46 rather than joining them as strings. To fix this, we should first convert each number to a string using str function, then concatenate them. After making this change and running the program again, we see that the output is now 1234 as intended. When developing applications, a common task is to handle user input. User inputs are usually received as strings, even if the user intends to provide numerical data. To perform calculations, comparisons, or other operations, it's crucial to convert these inputs into the appropriate data types. Let's calculate a discounted price based on a user-provided input. Entered value equals input. Enter the price. This line takes a value as input for the price. To check the type of the entered value, we use the type function. When we run the program, it prompts for input. After typing a value, we can see that the input is of string type because the input function always returns a string. Since we can't use a string directly in calculations, we need to convert it. We do this by writing price equals float of entered value. This line changes the string input into a float number. Now, let's check the type of the price variable using type function again. After running the program and entering a value, we'll see that price is now a float. This means we can use it in our calculations without any issues. Now, we remove the lines related to the type function and complete the rest of the code. Discount equals price times 0.2. Print discount. This line calculates a 20% discount by multiplying the price by 0.2. The result is stored in the variable discount. Finally, this line prints the value stored in discount to the console, displaying the calculated discount. We hit the Run button to start the code. The program prompts for input, and we enter the value of 22.5. As a result, the discount amount of 4.5 is printed in the output. Type conversion in Python can be extremely helpful, but it comes with potential pitfalls that can lead to bugs, errors, and unexpected behavior in our code, especially when dealing with user input or data processing. Here are some common pitfalls to watch out for when performing type conversions. When converting between types, especially from floats to integers, there can be a loss of precision. Floating point numbers are truncated, not rounded, when converted to integers. For instance, nomfloat equals 3.99. Nomint equals int of nomfloat. Print nomint. Let's run the program. First, the variable nomfloat is assigned the value 3.99. The int function is then used to convert nomfloat to an integer, which is stored in the variable nomint. Int function truncates the decimal part of the float without rounding. Finally, the print function outputs the value of nomint, which is 3. This shows how type conversion can change a floating point number to its integer representation by discarding the fractional part. Not all types can be converted to each other. Attempting to convert incompatible types, like a string that doesn't represent a number to an integer or float, will raise a value error. The next example is a basic program that takes an integer input and prints it. Answer equals input enter a number. Number equals int of answer. Print number. This line prompts the user to enter a number. The input function gathers user input as a string, regardless of whether they enter numbers, text, or symbols. This line tries to convert the input stored in answer to an integer. If answer contains a valid integer string, it will convert successfully. However, if answer contains any non-integer characters, such as letters or decimal points, it will raise a value error. If the conversion is successful, this line will print the integer value. We will test this code with 3 different scenarios, first with an integer value, and then with 2 non-integer values. Scenario 1. Entering a valid integer value. When we enter an integer value, the code runs without issues. The input function takes 2 as input and stores it as a string in answer. The int function successfully converts the string to an integer. Finally, the integer 2 is printed to the console. Scenario 2. Entering a string value. If we enter a string, like ABC, The code will raise a value error because ABC cannot be converted to an integer. When we call into answer, Python attempts to convert ABC to an integer, which is impossible since it doesn't represent a valid number. This causes a value error, stopping the program and displaying an error message. Scenario 3. Entering a decimal value. Even if the user enters a decimal number, like 4.0, the int function will still raise a value error because it expects an integer. Although 4.0 and 4 look similar, the conversion fails because the input contains a decimal point. To handle decimal values correctly, we can first convert the input to a float and then to an int. The program attempts to convert the input string to a float using float of answer. It then converts the float to an integer using int function. Now, if we enter 4.0, it will convert to 4 without causing an error. This code demonstrates the need to handle type conversions carefully when taking user input. However, it has pitfalls when dealing with non-numeric strings or decimal numbers, leading to value error. Boolean type conversion in Python can indeed lead to some unexpected and surprising results. When we use the bool function to convert various types to Boolean, we may encounter situations where seemingly false values still evaluate as true. Let's review these examples. In each of these cases, the bool function converts these values to true. This happens because any non-empty string in Python evaluates to true, regardless of its content. As a result, false, a single space, and 0, which may look like false values in other contexts, all return true because they are non-empty strings. To avoid pitfalls, use explicit checks, understand the rules of truthiness, and be mindful of the context in which conversions occur. By doing so, you can ensure that your code behaves predictably and logically. In Python, none is a special type that represents the absence of a value. While it's generally used to indicate nothing or no value, it can lead to unintended behavior when interacting with other data types. Type conversion involving none occurs when we attempt to treat it as if it were a different type, or when we accidentally perform operations that implicitly convert none. Let's explore 3 examples to see how none behaves when converted to different types, along with the results and pitfalls of these conversions. Let's start by creating a variable x and setting its initial value to none. Next, we convert the variable x to a Boolean value using the bool function and print the result. When none is converted to a Boolean, it evaluates to false. This behavior is consistent with other false values in Python. Let's turn none into a string using str function. When we run the program, the output shows none as a string rather than the special none object itself. It's important to understand that str of none produces the string none, which is different from Python's none object. The string is just text that can be printed or manipulated like any other string, while none represents the absence of a value. In the third example, we use the int function on the x variable. Converting none to an integer raises a type error because none cannot be represented as a number. Python has no default numeric equivalent for none, so it cannot be cast to 0 or any other number. This is important when processing numeric data with possible missing values. It's best to check if a value is none before converting it and either skip the conversion or replace none with a default value like 0. As you can see, the conversion of none can lead to different results depending on the target data type. To avoid these pitfalls, always handle none explicitly in your code and use conditional checks to ensure appropriate handling for each case. While type conversion is a powerful feature in Python, it can lead to unexpected pitfalls if not handled carefully. Understanding the nuances of type conversion in Python is crucial to avoid unexpected behavior and errors. We've already encountered type error and value error exceptions during our exploration of type conversion. Both exceptions are raised in different contexts, signaling different types of issues in our code. Let's dive into what sets type error apart from value error with examples to make it clearer. Type error occurs when an operation or function is applied to an object of an inappropriate type. Essentially, this error tells us that the data type of the object doesn't support the operation we are trying to perform. In this example, Python doesn't know how to add an integer and a string, so it raises a type error. Python is essentially saying, I can't perform this operation with these types. To solve this problem, simply convert x, which has a string value, into an integer using the int function. After execution, there is no longer a type error, and the output correctly shows the number 15. A value error, on the other hand, occurs when a function receives an argument of the correct type but with an inappropriate value. This means that while the type of the input is correct, the value it holds isn't acceptable for the operation or function. In this code, attempting to convert the string $12.49 to a float raises a value error because the $sign makes the string an invalid float representation. The type of the input is correct for the float function, but its value is not. To solve this problem, we need to remove the $sign from the string. Since the argument type is correct as a string, we just need to correct the value to run without a value error. To recap, a type error is raised when an operation is applied to an object of an inappropriate type, indicating a type mismatch. On the other hand, a value error is raised when a function receives an argument of the correct type but an inappropriate value, indicating a value mismatch. By being aware of these common errors, you can write more robust and error-free code. To ensure smooth and error-free type conversion, always use these best practices. Explicit type conversion. Always use explicit type conversion functions like int, float, str, etc. instead of relying on implicit type coercion. Explicit type conversion makes your code more readable and avoids unexpected behavior. Be aware of loss of precision. When converting from a float to an integer, keep in mind that precision is lost. This can affect calculations, so confirm that precision loss will not impact the result. Validate inputs before converting. Always validate and sanitize user inputs before performing type conversions. Ensure that the input is in the expected format to prevent errors. Handle conversion errors. Always handle potential conversion errors using try-except blocks to prevent your program from crashing. Avoiding unnecessary conversions. Unnecessary type conversions can cause performance overhead. Convert types only when needed, and ensure that the conversion aligns with the intended use.